Have you ever wondered where stars come from? The cosmos, a celestial theatre that never ceases to amaze us, offers an answer in the form of nebulae, the cosmic cradle of stars. The universe, in all its infinite expanse, is filled with these celestial clouds of gas and dust, painting a breathtaking canvas of cosmic artistry. Nebulae play a pivotal role in the grand opera of stellar evolution. They serve as the nurseries where new stars are born, their light eventually reaching us across the vast distances of space. But how does this stellar birth take place? It's an intricate dance of physics and chemistry, where nebulae provide the raw materials and the perfect conditions for the formation of these celestial luminaries. Imagine a nebula as a gigantic, diffuse cloud floating in the cosmic sea. It's a place where the ordinary becomes extraordinary. The simple elements within these nebulae, hydrogen, helium, and traces of heavier elements, under the right conditions, transform into the brilliant stars we see adorning the night sky. But the story doesn't end with the birth of a star. Nebulae are also the cosmic recycling centers of the universe. They play a crucial role in the cycle of stellar evolution, ensuring the continuity of cosmic creation and destruction. When massive stars reach the end of their life cycle, they explode in a spectacular fashion, a supernova, enriching the surrounding nebula with heavy elements. These elements, along with the remnants of the exploded star, eventually become part of new nebulae, perpetuating the cycle of stellar evolution. The study of nebulae and star formation has long fascinated astronomers and astrophysicists, peering into the depths of the universe to unravel its secrets. Through their research, we've gained unprecedented insights into these cosmic processes, helping us understand the intricate details of stellar birth and the evolution of our universe. So, the next time you gaze up at the night sky, remember the cosmic cradle that is the nebula, the birthplace of stars. But our journey doesn't end here. Next, we delve into the different types of nebulae and how they contribute to the birth of stars. Nebulae are as diverse as they are numerous. Indeed, the cosmos is abundant with these celestial nurseries, each with its unique characteristics and beauty. Among the diverse types of nebulae, emission nebulae are particularly fascinating. These nebulae glow with an ethereal luminescence, a spectacle caused by the radiation emitted by nearby hot stars. Imagine a cloud of gas, primarily composed of ionized hydrogen, glowing with a characteristic reddish hue when excited by the ultraviolet radiation from these stars. That's an emission nebula for you. Let's take a journey into the heart of one such emission nebula, the Orion Nebula. This nebula is not just a glowing spectacle, it's a stellar nursery bustling with the creation of new stars. The Orion Nebula is a vast expanse of gas and dust, hosting dense regions known as molecular clouds. These clouds are the perfect environments for the birth of stars. Despite their incredibly cold temperatures ranging from tens to hundreds of degrees below 0 Celsius, these clouds are hotbeds of stellar activity. Now you might wonder how stars form in such cold conditions. Well, it's all about gravitational attraction. The particles within these molecular clouds are drawn towards each other, causing them to contract and increase in density. This contraction is the first step in the formation of a star. Within this contracting cloud, pockets of higher density form. These dense cores, composed mainly of molecular hydrogen and dust particles, are the seeds from which new stars will eventually emerge. The birth of a star begins when one of these dense cores becomes unstable and undergoes further contraction. This leads to an increase in temperature and pressure at its core, setting the stage for the creation of a new star. So, as we marvel at the beauty of nebulae, remember that they are more than just beautiful glowing clouds in the cosmos. They are the cradles of star formation, the cosmic factories where the raw materials of the universe are transformed into shining stars. Now let's delve deeper into the star formation process within these nebula. The birth of a star is a complex process governed by the laws of physics and chemistry. It all begins within the cold, dark confines of a nebula, where pockets of gas and dust, known as molecular clouds, start to condense under their own gravitational pull. These molecular clouds, despite their frigid temperatures, are the very cradles of stellar life. As gravity relentlessly tugs at every particle within the cloud, areas of higher density start to form. These dense cores, made primarily of molecular hydrogen and dust, are the seeds from which new stars will sprout. It's a bit like the kernel of a popcorn, waiting for the right conditions to pop into existence. Now, when one of these dense cores becomes unstable, things really start to get interesting. The core begins to undergo further contraction, and as it does so, the temperature and pressure at its center start to rise. It's like a cosmic pressure cooker, slowly building up heat and energy. But as the core contracts, something else happens. The law of conservation of angular momentum steps in. This law states that if no external force is acting on an object, it will maintain a constant angular momentum. What does this mean for our star to be? It starts to spin faster and faster, forming a rotating disk of gas and dust around itself. This disk, like a cosmic buffet, serves as a reservoir of material that will eventually be gobbled up by the growing core. This accumulation of material is what fuels the growth of the core into what we call a protostar. However, the process of accretion isn't uniform. Sometimes clumps of material stick together, forming planetesimals, and if they're big enough, they may even become planets. This sets the stage for the birth of not just a star, but an entire planetary system. But how does a protostar become a fully fledged star? Let's explore. The journey from a protostar to a star is one of growth and transformation. The life of a protostar is not a stagnant one. It is a dynamic process characterized by continual change and evolution. The protostar, nestled within a rotating disk of gas and dust, is fed by a process known as accretion. This process, much like the way a river carries sediment downstream, brings material from the surrounding disk onto the central core. The addition of this material fuels the growth of the protostar, causing it to increase in mass and size. Accretion, however, is not a uniform process. The material from the disk doesn't always smoothly glide onto the protostar. Instead, it can clump together, forming larger bodies known as planetesimals. Over time, these planetesimals can collide and merge, giving rise to fully fledged planets. In this way, the stage is set for the formation of a planetary system around the emerging star. As the protostar continues to grow, its core temperature and pressure also rise. This increase is gradual, but eventually, a critical point is reached. The core becomes so hot and dense that it triggers the onset of nuclear fusion. This is the process by which the nuclei of atoms combine to form heavier atoms, releasing a tremendous amount of energy in the process. The ignition of nuclear fusion in the core of the protostar marks a significant milestone in its evolution. This is the moment when a protostar officially becomes a star. The energy produced by nuclear fusion radiates outward, causing the star to shine brightly. Depending on its mass and composition, the star can continue to shine for millions or even billions of years, providing light and warmth to any planets that may orbit it. The transformation from a protostar to a star is a testament to the marvels of cosmic evolution. It's a process that has unfolded countless times across the universe, leading to the diverse array of stars we see in the night sky. But nebulae play a role beyond just the birth of stars. Nebulae are crucial players in the cosmic cycle of birth, death, and rebirth. They are the great recyclers of the universe, taking in the remnants of stars that have reached the end of their lives and using this material to fuel the formation of new stars. Imagine a star in its final stages, having exhausted its nuclear fuel. As gravity pulls inward, the star can no longer maintain its equilibrium and begins to collapse. In the most massive of stars, this collapse triggers a supernova, a spectacular explosion that releases enormous amounts of energy and ejects the star's outer layers into the surrounding interstellar medium. This explosion enriches the nebulae with heavy elements, the building blocks of planets and life as we know it. These elements, along with the remnants of the exploded star, are swept up by the nebulae, becoming part of new molecular clouds. In these cold, dense pockets of gas and dust, the cycle begins anew, with the formation of new stars and planetary systems. And so the death of one star sets the stage for the birth of others, in an ongoing cycle of stellar evolution that has been playing out for billions of years. This cycle is not just a cosmic carousel of birth and death, but also a process of transformation and growth. Each generation of stars enriches the nebulae with heavier elements, leading to the formation of more complex structures over time. It's a process of constant change where chaos and order dance together in the cosmic ballet of the universe. In this vast expanse of space filled with nebulae and stars, we find a deep sense of wonder and a profound understanding of our place in the cosmos. For it is in these stellar nurseries that the atoms that make up our bodies and the world around us were forged, linking us to the stars in a cosmic chain of being. From nebulae to stars, the universe is a marvel of constant evolution and transformation. By understanding these processes, we gain a deeper appreciation of our place in the cosmos